Alright guys, in this video, more like a lecture, I'm going to be demonstrating and building the entire air system for the Eaton 13-speed, 15-speed, the Eaton transmissions, the ones you find in big trucks like that, and a lot of these transmissions are still used today. There's another one. There's a 13-speed. This one is technically a 9-speed. It's an MLL. But all of them have these components here. The regulator, the slave valve, which looks like that, a range shift stick, or control valve, and this is an older model. Some of them have same valve. This is the same valve, just in a different shape. And in the newer trucks, you'll see something like this. But I am going to be starting from basic concepts, so by the end of this video, you'll not only understand how the entire air system works, but you'll also understand and be able to determine any air system. And the basic concept is all these things, the slave valve, I think this is called a two-way valve, this relay, they're all valves. These things, they're all just simply valves that are turning air either on or off at different ports. So starting from a basic valve, a plumbing valve. By the way, the air, liquid, and electricity work in the same way, so the same concepts interchange. So basically an on-off valve is the same as an on-off switch for electricity with very few differences. So a lot of the concepts will be the same. So, and also the plumbing parts and hydraulic lines, hydraulic fittings, and air fittings, again, they all interchange. Although you have to keep the pressure in mind, so certain air fittings won't work for hydraulic, but hydraulic will definitely work for air. And so you just got to keep the pressure in mind. So starting from the simplest to the simplest valve, this is just an on-off valve. That's on, it's in line like that, and it opens a hole inside, and then when you turn it off, it closes that ball valve inside. Like that, closed, open. And with this system, let's say you have air or water inside that have connected to this pipe and then to this gauge. Let's suppose that air is in this system. The valve is open, air is inside. The gauge will be reading our air pressure here. Now, if I just close this valve, not much has changed. If the air inside this pipe, like it is right now, has nowhere else to go, it'll simply remain pressurized. Now, in a house, when you have running water, the water inside this pipe will still be used even after you close the valve. So in the air system, it is the same. You close the valve. If this were to be open, air would escape and until the air inside the pipe is drained. But in a system where it is closed, like inside a piston, there's no flow of air. Air is just stored. It's not going anywhere unless you empty it out. So when you have a faucet on, when you have a valve on, the water is running. But in a piston, like what's in the transmission, you can't have that air leaking. It's got to be stored in that piston. It moves the piston and then it stays there. So you need to find a way to empty that air out. So I went ahead and I changed the system a little bit. I added another on-off valve. So now, let's say this is our input. We now have two outputs. Before we only had one output, now we have two. Let's say I open this valve, air or water flows in through here. This valve is currently closed. And over here we just have the gauge, so air is stopped here. Right now, air is pressurized in the system. Now I close the air, input. There's still air in the system because it hasn't left the system. But now I am going to exhaust the system, the pipes and the gauge. So I open the valve and our air has now left the system. I would like to actually demonstrate this, but it's quite a bit of work hooking this all up, and I think you can follow the concept a bit abstractly if you have to. So now this is there's no air in the system and there's no flow because this valve is closed. Now I could also turn this valve on, and now we'd have a flow of air through here. So air goes through here, or air or water, and exits out through here. Now, this is pretty much what you need for a piston. So in this case, the gauge is representing our system. So if we have air pressurized, this valve closed, this valve, the input valve open, it would move the piston that way, right? And hold it there because it's pressurized by air pressure. Now, if I want to, I can't really cause this air to go back. You can't really do that, right? So what I need to do now is close the input valve so that no more air enters, and then I depressurize the system. And now the piston comes back this way. Now the problem with this system, the shortcoming with this system is I have to turn on two valves. And I have to turn them on in order. If I were to just open this one, then we just have a bunch of air pressure. And let's say this is connected to the air compressor on the truck. Then I would simply empty out all the air from the truck. So this isn't a very good system. You'd really have to know what you're doing. And if you make a mistake, then you'd run out of air on the whole truck, and that could be very dangerous. So we come up with the second valve, which is this valve. I think it's called, I'm not too sure, but I believe it's called a two-way valve. And this valve replaces this system and basically moves the two valves simultaneously. So while one is open, the other is closed, and while one is closed, the other is open because of the shape that this operates, and I'll show you just in a second. Now, the disadvantage compared with this system is that you couldn't do a few things that you could do with this system. So, for example, in this setup with the two separate valves, you could have them both open, and you could potentially have them both closed. You can't do that with this valve. When one side is open, the other is closed. But on a truck, that's exactly what we need. Now, the way this valve works is inside here, there's basically an elbow inside there. And basically, this is a plumbing elbow. This is called a male, and this is called a female because the male goes into the female's hole. So that's why you get the name from it. So whenever you see threads on the inside, that's a female, and threads on the outside like that. That's a male. Here's another elbow. This is a female to female. This is a female to male. And you have the size stamped on here, 1/2 inch. That's the standard size. So inside this valve, you have something like this. And when you move the lever, it shifts it from there to there like that. So as you can see, when it's like this side is connected to this side. So open to open, while this side is closed. And then when you move the lever that way, now it's the opposite. This side is closed, and this side is connected to this side, open to this side. So in a truck, when I have, again, I have the gauge representing the piston. When we'd have the air entrance over here, and this side would be the exhaust. And you have to pay attention which side goes to where. And again, these valves can be used in a few different ways, but the middle part in this case is the common. So you can either connect this side to that side, or you can connect this side to that side, but this side is always connected. So basically you have 2 inputs to 1 output kind of thing. Now in the truck, in the piston of the truck, you'd have air coming in through this side, and this side would be the exhaust. So right now you have air going into the piston. Piston's pressurized, it moves it. Now you want to turn off the piston and make it come back, so the air has to be exhausted at the same time. You flip this lever, and now it's like that. So now the air is closed, the air input is closed, the air inside the piston is free to escape the atmosphere, exhausts. I'm going to try to show you what that looks like on the inside. So as you can see, that is open, connected to this one. See the light going in there, while this side is closed. And then shift the lever around. Now it's the opposite. Now this side is closed, and it's these two are connected now. So relative to the middle part, you can either connect the middle to the left or to the right. Now, someday it would be really nice to disassemble this so I can actually show you. But a question that I've come across: could you potentially have it halfway so that all 3 of them are connected? In this case, absolutely. There, all 3 of them are connected now. So you can have it that way as well. All 3 of them connected. So you definitely, if you're wanting to empty out the system, you definitely couldn't leave it in the middle position like that. That would be, that would cause all sorts of problems. But since you're shifting it, you'd quickly just be going through that real quick like that, just for a split second, then it wouldn't matter. But if you were to forget this, like I said, forget that there, so that everything's connected, then you'd have all sorts of problems, because now the air from the piston and from the air tanks is just being exhausted into the atmosphere. And again, I'm talking about perspective where we have the truck. Now, in other applications, it could be different. You could just want, let's say, oil in here. Let's say some kind of excavator or a hydraulic machine. You have air going in here, or hydraulic pressure going into here. Then you'd want it going to all 3, and then maybe you just want it going to this one, and then you'd want it going just to that one. There's a few different ways you could go about this. Or you could have two inputs going into just one. But in a truck, since we're ultimately going to do the truck air system, that's kind of, this is how I have it set up. And I actually have it set up on my 1986 International, the S1900, and this actual valve here. I used to have a switch like this that was electrical, and I replaced it with that. All right, so anyways, now we're going to the next kind of valve, and again, it's a little bit more complex. Now, instead of you having the user with this valve, you have a manual, you have mechanical or manual, you're actually using your hand to move this valve. With this kind of valve right here, it's actually called a relay. Instead of you actually having someone move the lever, you actually have air pressure or hydraulic pressure making that movement, basically. And again, making a parallel to electricity, this is a Ford style relay, and there's basically 3 terminals. I know there's 4, but one of them doesn't do anything. Essentially, one of them is just another output. So you have, again, this is just a switch, but instead of it being activated manually, you have it activated electrically. So just like in a house where you have to actually push the switch to turn the lights on and off, when you get to this, or this, it's a bit more advanced, where you actually have one switch to turn on another switch electrically. So the second switch is turned on electrically. So in this case, you want to pass current from here to there. You want to join these 2 points. Instead of having it joined mechanically, like with having something across, you actually have to have an input here electrically controlling this to join them. So you have electricity going in through here as well to then join these 2. And basically the advantage is you have thin wires to turn on a big contact wire. So if I wanted to turn on a welder all the way over there, and I want to be over here, well, if I were to do it with just one big switch, I need a big thick wire going there and the switch over here, and then another wire going back there to join them. So, and that becomes a bit difficult because the wires are big and expensive, and on a truck, the big pipes could be occupy a lot of space. So you have 2 thin wires over here with this little switch connected to a relay like that, way over there, and then you just have the big wires from there to there. And similarly, you have little pipes like these to turn on, switch on the air, the big air pipes like these at the piston. But you could also just do what I did here and put a big pipe instead of a little pipe. And there's no harm done in that. It's a lot more heavy duty that way, and I actually do those upgrades sometimes. So usually the reason for doing these things is manufacturers just cutting corners, making things cheap and easier for them, or cheaper for them and harder for us, and less reliable for us as well. So similarly, on this kind of relay, here's our air supply, and in this case we have 2 outputs, which is del and del, which is delivery, and ex for exhaust. So, but you could just have one blocked off, and then you could have all sorts of different outputs. You could have just the same as if I were to put a T on here. So from there, going back to that valve, I could now have 2 outputs on this side instead of just one, right, like that, for this port, or 2 like this. So instead of having a T, they actually built it in with a port, so you have 2 deliveries. So our supply is basically our big line, as you can see. And this is the air that is going to go to the outputs. So this is the input. It's going to be connected to the outputs, these 2, the deliveries. And instead of having a manual lever, we actually need air to do this shift on this line. And on the manuals, they call these the pilot or the signal. And that's what this is. That's what the P terminal is, port, on the slave valve. The new one doesn't have a label there, unfortunately. So the old one does. P. There's a P right there, but there's no P on this one. All right, so basically with this relay here, basically, again, we'd have, and as you can see, the pilot lines are always smaller than the big lines because there's no point in doing it with the same size lines. And imagine we're just scaling this up to like a big pipeline where the pipes are like this thick. You can't really have an actual guy there shifting a big lever. You need it to be the press of a button, small force controlling a big force. So this is what this is. So over here you'd have a small pipe like that, and you'd have a valve. Unfortunately, I don't have the right size valve for it. And then you'd be with this switch somewhere else, this valve somewhere else, let's say way over there on that tree. Turn the air on there, air goes on and through here and connects these 2, connects this to these 2 outputs to wherever we want them to go. So in this case, in the truck's case, you have this valve. This would be your brake switch. And by the way, with this thing, so that's the main difference too. With a manual operated valve, you actually have to be at the valve to move it. Whereas with this here, you can be somewhere else to control it. And that's why it's necessary for truck brakes. So this actually happens to be a truck brake valve. So if this were to be the truck brake valve, you'd have to step on it and to open and close to activate the brakes. But the brakes are way over in the back. So how the hell are you going to, from the cab, move that lever all the way there? You couldn't. Unless you had some kind of shaft going from all the way from there to there. And some cars actually had that. But to make things simpler, you have this here. So with this here, with this kind of valve, you can be inside the cab and you can activate that valve all the way in the back. Could you have the pipes connected this way all the way into the cab? Absolutely, you definitely could. But with the smaller pipes, it just makes this easier. Now with this valve here, you couldn't. Like I said, unless you had a mechanical shaft to move this. So finally, moving on to the final explanation with a slave valve. This here is doing exactly the same thing, but it's basically this and this together, or 2 of these together plus the neutral switch in the back there. But it's still the same concept. Right here we have our supply, or our input, where the air comes in, constant air. And then over here you'd have P, which is our pilot or our signal. And this is what actually is going to be turned on and off from the remote switch. You still need a remote switch. And L high and L are just our outputs. L and L are the same, and high is our other output. Now, When I said it's basically, the slave valve is basically these two together, or two of these together in a way, is because when you turn the low on, you want the high off and exhausted. And when you want the high on, you want the low exhausted. So I could actually replace this valve with two of these. Now, just one of them wouldn't work because, remember, I need an input, an exhaust, and our output. Well, since we have two pistons, we need two inputs, two outputs, and two exhausts. So you need two of these valves. And I actually seen two of them that actually come together for sale. Pretty expensive, but it could definitely be done. And these are cast iron, whereas compared to these, a lot more flimsy. And one other important difference to mention is this thing is completely steel. It's cast iron and steel. It's solid iron. It's pretty heavy. I think this weighs at least half a kilo, like 2 pounds at least. Whereas these things are aluminum, they corrode pretty fast, and there's actually diaphragms inside here. And with this one, with the piston system, you can see a separate video of the disassembly of a slave valve, by the way, separate video. It actually has seals, flimsy little O-rings, and O-rings. So O-rings deteriorate over time, and they deteriorate pretty fast when exposed to certain oils or chemicals. So this here is definitely a lot stronger than that and that. Do they have any cast iron slave valves, something like this? I don't really think so. Now, the other thing with the slave valve is it's actually got a mechanical through this hole, a plunger that comes in from the transmission and doesn't let the valve move unless you're neutral. So if you were to move, when you press the button to actually move the piston in and out of gear, in and out of high or low range, it doesn't actually let you do it unless you're neutral. So still, it's the same thing. You have an input, you have the outputs, and you have the signal, the pressure that needs to be applied in order to move the piston. So by applying air pressure here, it moves the piston that way or this way. Alright, so continuing on with the air system for the transmission. Before I disassemble this slave valve further, just remember from the other video, or I have a separate video actually that shows, but anyways, you can see here that this is the S port, or the supply. Air goes in through there, and then through this hole, and to that hole, right? So they line up there. So that's our supply hole right there. And as you can see, the piston on slave valve is just free to move. There's no spring that holds it in a certain position. And then the air from there goes through the hollow shaft on this piston and out through this hole, and then it goes to either high or low. So you can see the hollow shaft right there. But the interesting thing is, so air pressure has to be applied. Air pressure is normally applied to this side. So as soon as the truck builds up air pressure, it's going to try to push this valve that way, which is the high port. But if the valve is on the low range, you'll also have air going to this side, and you'll understand that in a bit. But on this side of the piston, As you can see, the air goes in directly to the face, so it applies to this whole face of the piston. Whereas on this side, the force only applies to around the shaft. So if you read on the manual, it says that the piston has a greater surface area on one side than on the other side. And this is not only for the high-low range piston, but also for the deep reduction piston. And the overdrive or the splitter piston, but it also applies here. So on this face, on this side, the air applies to the entire face, the force of the air. The PSI, the pressure is still the same, and this is a bit of a physics class now, but pressure is force divided by area. If you have a smaller area, you have less force. Still the same pressure, but less force. So you have the entire pressure applying to the entire surface here, which is a lot bigger than on this side, because on this side you have this shaft, which doesn't, right, the air can't apply there because it's got because it's solid, right? Like the shaft is in the way basically, so the air can only apply around the shaft, which means that when air is applied this way, there's still air on this side, but the force on this side is greater, so it pushes the piston that way. Now, if you realize that the supply side always has air pressure, it's the constant air pressure side, so it's not exhausted. The low and the high range sides are exhausted, but not the supply. I like to make a little analogy, so just a little analogy so you can understand how this valve, the slave valve, works. Say this pipe is the supply. This has always constant air pressure. Nothing controls this, in the air inside it at least. And then you have two outputs, and the supply moves that way or this way. And the P, or the pilot, which is the control, is, say, this pipe here, this fitting here, and its pressure is what causes the the supply to move that way or this way. So this system, compared to this analogy here, this would be the high and low, this would be the supply, and this would be the P, or the switch, if you will. I like to call it the switch. So all the constant, or the supply, all it does is it moves and it supplies air to different ports. The P, or the pilot, is what controls the supply to go into a certain port. So now that I demonstrated that, let's actually connect the slave valve. I actually connected the slave valve, and you'll see the practice. So all I have is a gauge, an air gauge on the high, an air gauge on the low. I've got nothing connected to the pilot, and this is just going to demonstrate how the normal position of what I was saying, the normal position on the slave valve is on the high. And that is a bad thing. That's why the truck gets stuck in high range, because as you can see, I have no air going to the pilot here, and I'll show you in just a second. I'll actually turn on the pressure here, but if you literally take out the slave valve, or sorry, you literally take out the high range shift valve, or you cut a line here, it's going to cause the transmission, and this is still working fine, but you have a problem up here. This is going to cause the transmission to shift into high, and then you're stuck in high range. Or if the problem here happens while you're driving the truck, you could actually damage the transmission. So before I say anything else, I'm just going to demonstrate what's happening here. So here's our supply, and over here I have it connected from the regulator, the output of the regulator, and then the other output of the regulator, I have it connected to the high range valve. shifter, but we're not doing anything with that now, so just forget about that for now. It's closed, so we're just doing this side for now. And I have the input here from the compressor. Just turn the pressure on, see what happens. Got a little bit of a leak in these fittings here. Just temporary. And as you can see, no air leaks through the pilot because, again, it's like two separate sides of the piston. So you can just have this open to the atmosphere like that, and no air leaks out past it because air is going through that side of the piston. It's coming to, as you can see, the high, whereas the low has no pressure. So this just proves that if whatever problem you have that causes a lack of air pressure, and that's usually the case, you can't really pressurize a line that's not got pressure to it. You can lose pressure, but you can't really transfer pressure. So that's not really a really realistic problem. So what's going to actually happen is you're going to lose pressure. So whenever you lose pressure from this side, because this is what controls the slave valve, and that's why the name is slave, because it's a slave to this. All this does is obeys what the high range shifter tells it to do. The only thing that it doesn't obey from here is the neutral plunger from the transmission, which is this here. And make sure you have this going in this way and not that way. But in terms of our shifting here, as you can see, the normal position of the slave valve is on the high range. So if you burst a line up here, one of these shitty flimsy little lines, or it gets clogged or bent, then the transmission automatically stays stuck in high range. And by the way, I have the input connected to the regulator, so air is coming. Here's the input from the compressor. Right, the line from the compressor. It's 110 psi. It gets regulated down to 60, and it just continues on this way. But you could just connect this here directly to there. And you know, some air compressors, a lot of them have have an air regulator on itself. It's no different than this here on the truck, and actually I might actually do some experiments with that later on. But anyways, you could just connect air pressure to this directly. I just don't like doing it because there's O-rings, and as I showed you, there's little shitty seals, and without the regulator you'd be applying 2 times the air pressure. But in my case, I could do it because I have the air pressure low anyway. So anyways, what I'm saying is you could just connect the air pressure directly to here. Alright, so now that I've proved that and done that, let's actually complete the system, the remaining pipe, which is the pilot. So from the output of the regulator, I have it going to the input of the range shifter, and then the output, or the outlet, will come into here, into the P of the slave valve. And basically what's going to happen is, right now the air is closed, air pressure has to be applied here to move the piston on the slave valve that way, so that it opens the port to the low. So just so you understand again, what I'm saying is you actually have to apply air pressure to get into the transmission into the low range. Whereas normally it's on high range. And I really hate this, because once again, if you have to be stuck within a certain range, you definitely rather be stuck in low range, because you can still drive the truck slowly, but you can still easily drive the truck from low range. But you can't, or it's almost impossible to drive the truck if you're in high range, which is what happened to me. I was at the bottom of a very steep hill and I was stuck in high range, and then you can't go up the hill. Whereas if you have the low range, you can go through anything, but with the high range, you can't do that. So I really wish they had designed the system the other way around, so that the supply is normally to the low range and you have to apply air pressure to get into the high range. But this is the way they have it set up. That's why I actually, in another video you can watch, I actually made a bypass valve with one of these things, so that you could apply air pressure directly to the low range, to get into the piston to the low range in the case of an emergency or a problem with this system. But still, again, like what I'm saying is, all it would take for the transmission to get damaged, for you to skip out of gear while you're driving, is one of these shitty lines gets clogged, and they're tiny, they're minuscule, or one of these rings, O-rings or seals in these parts to become damaged. So it is really the weak link, or the Achilles heel of this system. So yeah. Right, so the final pipe of the puzzle, I've connected the outlet of the high-low range shifter, the range shifter, to the P-port on the sleigh valve. And once I turn the air on, the valve is up. The air pressure is going to be 50 psi or so on the high, and then I push that valve down. Little air from the gauge and the pipe is going to be exhausted through there on the sleigh valve, and through that little hole there on the range shifter, and then air is going to be applied to the low range. And I've just blocked this one off here, but it's the same as that one. I couldn't fit another gauge in here, and no point, because we know that these two are exactly the same. They're connected. So I'm going to turn the air pressure on. And right now we're in high range, and low range is empty, as it should. Let's see what happens when I slowly being exhausted, or what? It's odd. It should be. Why is air pressure not being transferred to... Oh, maybe my air pressure is too low. Did I exhaust now? I think we're too low on the air pressure, and I have to... And as you can see, guys, I'm stuck in the high range for some reason. Brand new sleigh valve, and I did test the range valve, so I'm gonna fill up the compressor and see if that's a problem. But yeah, something is something is off here. So I have the range valve on the low, And I'm disconnecting that slave valve just to make sure I have air pressure coming out of it. At just about 20 psi. We do have air pressure, so valve is working. So I think my theory is that because I don't have enough air pressure, the air regulator is actually supplying more air to this side, and somehow the force on the piston pilot is not strong enough to overcome the piston and make the move. Just make sure this isn't seized though. Uh-oh, I think this thing might actually be seized. On this valve, it's moving in and out easily. And over here, it's... So this piston should move in and out pretty easily. So should this one. This fucker might be seized. It's a brand new valve, never used. Oh man. Well, we'll see with the high pressure. It might work. All right, so I just pushed a bolt in through the end of that piston to move it that way, and did move, but it's not coming back, so it's kind of stuck in there, probably because you don't have enough air pressure to move it. All right, I got the air pressure to 150 psi now at the compressor, and believe me, that was a little bit more work than what I showed on video, because I have the compressor running a stereo ignition coil from this battery, and then this battery died, so I had to bring out the rambler, recharge the battery, and the little capacitor there was also kind of with a bad contact with the ground, so I had to just stuck a piece of twig in there. But now that I'm 150 psi on the compressor, let's turn the valve on, and we're at about 50 psi on the high range, and let's see if it'll make the shift now. Yep, sure did. Now in low range. Let's ready to see again. She could, there. It's low range. High range. I'm going to show you the back of the cylinder. It'll be pretty cool so you can see what's happening there. Back of the slave valve. Still going a bit slowly though. It's high range. It's low range. High range. Low range. So now all you have to do is connect the, replace the gauges with pipes actually going to the cylinders. So you have high going to one side of the cylinder, low going to the other side of the cylinder, so that when one pressurizes, the other exhausts, and when the other pressurizes, the one exhausts. So I think that pretty much concludes the air system on these transmissions. I hope this helps fellow truckers and fellow mechanics out there. If these videos were useful to you, please remember to like and subscribe, and tell other people about my videos, because the views certainly helps me get a little bit of money, and makes me happy and keeps the videos going. So, but anyways, thanks for watching. I hope it helps.